Good night. Well, guys, it's always a pleasure to be here. So thanks for inviting me. And you can hear me right? The sound is good. 1, 2, 3 testing. Yeah, can you hear me? I will assume that you can.
Yes.
Okay, great. So before starting with my talk today, please allow me just two quick messages. Okay, the first one, it's a kind of a personal one. Today for me, it's a really important day. 30 years ago, my wife actually accepted to be my girlfriend. So I know that she is also in the audience. So a big kiss to her, to my two girls. Okay. The second message, it's actually an appreciation word to the organization. I know that it takes a lot of effort, a lot of time, lots of hours to build something like this, and especially when you are doing it with a nonprofit and when you are doing it for the community. It's also something that I try to do myself, something that I appreciate. So also from my side, and I believe I will be speaking on name of everyone in the conference. Yesterday it was a great day, so today for sure it will be even greater. And thank you all for your efforts to putting this together. Okay. So starting now with the talk, and to give you some context about the talk. As you know, context is really important when we are talking about testing, and it's also important for this talk to understand. So it's still before 8 o'clock here. That's why I need a coffee, and that's also another reason why I will be doing a light talk. Okay, so this will not be a heavy talk; it will be just a light talk, and I will try to share some ideas, some hints. Some pointers on how to improve your test report. I will not get into much detail because, as I said, it will be a light talk. But if you have more questions in the end, please feel free also to reach me, to contact me. Okay. So talking about context, are you familiar with these, the tester skills quadrants? Probably some of you are, some will be seeing this for the first time, but this is one of the reasons why I believe that to be a tester, it's actually a challenge job. You need to know about the test knowledge, you need to know about the domain, you need to know about IT, and you also need to know about the soft skills. So you need to work, not just to know about them, but to be able to exercise them, right? And if you look to the training sessions, they are mostly focused on the test knowledge, where you have the training, you have the certifications, you have all those great YouTube videos where you can learn in 1 hour how to become an expert on test automation, all of that. Business knowledge, well, somehow or the other, you will need to learn the business, right? If you are not able to understand the business, you will fail on your role as a tester because you will not be able to use the shoes from the user. You will not be able to see the solution that you are testing from the eyes and from the experience of the user. IT knowledge, we are building software, so you need to understand the process. You need to understand the different process that will end up with the testing on your side, right? The input from the analysis, configuration management, the release management, all of that are quite important. But the soft skills, we tend to not forget. We know that is important, but we tend to not work them. Okay, so we tend to forget a little bit these soft skills, and they are quite important. Communication, critical mindset, presentation, reporting, and basically the context for my talk today. It's what I have observed on this part of the soft skills. So the lack of some soft skills, especially on the reporting, but also on the critical mindset. And if you remember one of my challenges when I was introducing this talk was if you are, producing reports that you believe no one reads, okay, the reports that are not adding value. So something is wrong there. And to be honest, I believe that 80% of our teams are really good at testing. Okay. Well, the remaining 20% still needs to improve. But one thing that we are not good at, it's selling. Only 20% of the testing teams are really good selling it. If you look to the developers, to the analysts, to the PMs, usually they sell quite well what they are doing. QAs, basically, or testers, they just suck when they try to sell what they are doing. Okay, they do a good job, but they fail to sell and to explain why they are doing a good job. So these soft skills are not easy, and you need to work on them. Okay, it's not something that you learn, that you born or not with it. It's something that you can train. It's something that you can learn. So today, let's try to work a little bit on this. Okay. So going to the scope of this slide talk. So I don't like pies. So why not? And you can say, well, pies are like pizzas, right? You can always find one pie or one pizza that will fit your taste. They can be sweet, sour, with veggies, with meat. You just choose. You can find them everywhere and for everyone's taste. Well, actually, what I like are pie charts. Okay, and to be honest, when I start doing some research for this talk, I realized that I'm not really alone in this. You have huge communities, you have lots of posts, especially on the data visualization communities, against the use, or let me rephrase, against the wrong use of the pie charts. And in most of the case, when we use pie charts, actually the best option will be, or should be, not to use them, just use some different chart. Okay. And just because I know that you have different flavors, so pizzas, pie charts, or even these donut charts, they are basically the same. Okay, just a slight different representation, but we are talking about the same type of charts. So with the same challenge, with the to pass the information. And even if you use what I call the rectangular pizza, okay, it's still a pizza chart. Okay, different shape, but it's still a pizza chart. So you will face the same challenge. So pie charts, why not? Okay, why shouldn't we use pie charts? And actually, they are not easy to read. Okay, when we look to the pie chart, it's more about the angle than the area. Okay, so humans suck comparing size. Okay, guess what? And if you look to these two charts, to these two pie charts, you can easily guess that the one from the left, because of the angle, this should be 25%, right? Easy to guess that. But what do you think about the second one? The angle is a little bit different. Okay, is it also 25, just with a different angle, or is it more, or is it less? Okay, so we looked at this not from the size perspective, but from the angle perspective. Okay, and actually this one is a little bit more than the 25, 28, but it's really hard to get that information from the chart. And if the chart is failing to convey the information, the data behind it, then most probably it failed on the purpose. So the second part where you should not use pie charts, it's because they are not easy to compare data. Okay, so the bar charts are much better for that purpose. They are much better to demonstrate the patterns in the data. That's in most of the case what you are looking for. So when you look to these A, B, and C pie charts, and this is probably one of the most common images that you will find if you search about pie charts and why not to use them. If you look to this, you will struggle to understand what is the pattern between the three different ones, besides the colors, of course. So what is the biggest? What is the smallest? Are they increasing from A to B or from B to C? But if you look for the same information using bar charts, or in this case, 3 different bar charts, it's clear, right? You can see that the red, it's smaller in the first one, and it's the biggest one on the last one, on C. So this is just one way to show that pie charts are not really the best tool when you're trying to compare data. And they are also not so easy to show trends. Okay, so yes, you can group sets together, and they make it easier to read, easy to understand. But if you are trying to compare, for example, these 2 pie charts, it's really hard to understand what is changing from left to the right. Okay, because of the different angles, because of the different areas, different sections, different categories. Yes, you can use the pizza chart, okay, the rectangular pizza chart in the bottom, and you can compare it easily if you keep the same order. So it makes it a little bit more easy to compare. But you have better ways to do it. So you can just use 2 different bar chart, and even without the colors, you understand what is the category with a higher volume of data. And even better, if you group the sets, you can start to see the pattern, right? So you can start to see that all these categories have exactly the same value, and the only difference is on these 2, where in the first one it increased, and on the second one it increased the total amount. So the same information using the 2 different pie charts, it will be much harder to convey, much harder to understand. And probably on top of the charts, you will need to write some more text to explain it, okay? Well, the pie charts are not easy in a lot of things, but they are also easy in some others. Especially, they are easy to make them worse. Okay, so it's really easy to make a pie chart even harder to read. Probably that's why the politicians, when you have these elections, they always like to use pie charts, because they can always make them look nice. And in the end of the day, no one loses, right? It's always a positive trend. So pie charts are quite good on that. You can always see the good side or the bad side of it, depending on what you want. And if 3D is not enough, you can go next step. But it's use 3D and even some transparency on top of it. Okay, and then you can play with the colors. And in the end of the day, the information that you can get from these type of charts, it's almost zero. Okay, so you can understand that you have some bigger areas here, this green, but that's it. It's really hard to understand the remaining information. So if they are not so easy to convey the data, why are they so common, right? Why are we seeing them everywhere, or almost everywhere? Well, if you look to the major, I would say, test management or defect management tools, you will see that the most used chart, or the one that is available in all of them, it's a pie chart. And again, all these different variants. Okay, so you have the pie chart, you have the donuts, and you have also the rectangular pizza, but they are all the same in the end of the day. So they are just available, and they are really easy to build from user point of view, but also from the tool point of view. So they are only showing a snapshot of the data. So you don't have, or you don't need to have any historical data to build those kind of charts. Right? It's not like you have a progress. It's not like you have a trend. You just have the snapshot. So really easy to build them. Anyone building charts on PowerPoint knows how easy it is, right? You just need to provide some values and some percentage, and you have your pie chart. And you also don't have or don't need to have any context at all. So it's just a snapshot once again. Okay. So that's why I believe they are all so common, so available, so used everywhere. Okay. But take a look to this, no context. Okay. If you remember some slides ago, I said that testing needs the context. The testing is context dependent, right? So guess what? Testing reporting is also context dependent. Okay, so you cannot ignore the context when you are writing your reports. So if you are using a tool, in this case pie charts, that don't provide any context, probably they are not the best one for your test reports, because in the test reports you need to provide context. Okay. Most of the stakeholders that will read your test reports will have just a couple of minutes to understand the information, to understand the main message that you are trying to convey there. And if they need to go through a huge text just to understand the report, or just to understand the chart, or to understand the main point in the chart, then you already lose them. Okay, so the information needs to be easily accessible, easily understandable in the report itself. So, are there any better ways to convey this data, to have better charts? Yes. And the S-curve is your friend. And if you are not familiar with the S-curve, as you can see on the left side, you can easily guess why it's called S-curve, right? Because of this S shape. And it's actually used in different business areas, but it always have this shape, and always with the time on the bottom, and with some quantity, with some growth on the left side. Okay, so what is this S-curve? And we have different definitions. So from the mathematics, they will say that this sigmoid function, it's a function with the characteristic S-shaped curve, as we saw in the image. From the business point of view, you can also see this, for example, when you are starting a business, and it will not be a straight line. It will not be like, you start from zero and then you always have new customers that skyrocket. Oh, usually you start slow, and then you start to get some speed, and towards the end, when you already have the market, your market share, then it tends to stabilize, right? But it can also be applied to project management. And this basically a chart, a graph that will show relevant data, cumulative data, and this is the keyword, okay, cumulative data for a project, depending on the metric that you want to use. It can be story points, it can be hours, it can be lines of code, whatever, plotted against a timeline. Okay, and again, you will start seeing this. So in the beginning of the project, the team starts slow. Probably you have less resource. They are still learning the business. They are still doing the analysis. So they are not really delivering something. And then they start to deliver fast, right? And then in the end of the project, when we start to get into the maintenance phase, probably you will have less resource. You are not delivering at the same speed. So you will start to slow down. So in this case, you also have this S-curve. So you can see this simple as a graphical display of the cumulative quantity over time, okay, plotted over time. So why do you need S-curves? Well, going back to test management, we have this important phase that is to plan and to control, right? We need to build our estimates, and then during the execution, we need to monitor and to control the progress against the estimates. So this is something where the S-curves can help. We also need to report on progress. usually on the test case execution or test case specification, where we need to report the progress day after day, week after week. And at the same time, we also need to report on the quality. So progress and quality, right? On the quality, we are talking about the number of defects or status of defects over time, to understand if we are ready to ship it or not, if we are ready to go live or not. So, and the S-curve is actually a method that can answer to all of these needs, okay? And we can, when looking to the S-curves, we can divide these in 4 different stages. The initial slow growth, so the initial part of the curve, where you are starting your test execution, you are finding those main blockers, so you are not really able to progress a lot, right? You are still getting up to speed, so you have a slow start. And then you have what is called the first inflection point. It's when the curve shape change. It's on the bottom part of the S, and then it's when you start to see the rapid growth. So the team already knows the business, they know what to do, they know what to test. The main blockers were already resolved, and it's when you start seeing the speed of the team, right? It's when you see the bulk of the defects coming through. It's when you see the bulk of the test case being executed. On a third stage, and after the second inflection point, and the second inflection point, it's when on the top of the S, when the shape changes again. At that stage, most of the test cases were already executed. So you are just doing some retesting, you are confirming some bug fix, but there is not much to deliver at that stage. So the speed is also slowing down. And the last part, just before finalizing, the last part of the S shape, it's probably when you are just getting ready for the go live, when you are getting ready for the launch, you are just doing some regressions, and you have just a few defects or no new defects at all. Okay, of course, this is the ideal scenario. We know that, as Boris said yesterday, it's not always black or white. Sometimes it's gray. So sometimes the things don't go according to the plan. But these are the 4 stages of the S-curve. So, and what you need to build an S-curve? Well, you need a tool, and you don't need an expensive tool. Just a good old friend of the testers, Excel or Google Sheets or any other spreadsheet program. And you don't even need some expertise on these tools, just basic knowledge on spreadsheets. And then you need estimates. You need to know the duration, and you need to know the estimated quantity. And again, this is applicable for both. You remember the progress and the quality, test case and defects. Okay, so you can build the chart for these 2 dimensions of data. And a very important thing, you need to collect the data over time. And I would say this is the most challenging task, because most of the tools that we have in the market will not allow you to have this historical view on the data, right? So you can just get a list of defects, but you cannot get a list of defects on a specific date and to find out what was the status. If you get the list of defects, you will get the list of the defects as they are today. If they are closed, if they are in progress, open, you will get the status on the current date. So you will not be able to have this historical date. You will not be able to build the trend. So it's quite important that you collect this data, and it can be, in a 20 days project, probably you will collect it by day. If it's a 6 months project, probably you will collect it by week. So it depends on the duration. And again, you can do it for test case, for defects, or for both of them. And later, but not least, with all this information, you just need to build your cumulative chart. Usually I recommend a bar chart, but you can also use area chart with the data that you collect. Yes, you can use tools that will help you to collect this data, using analytics tools that connect to the test management tools, and then they will help you to build that. Usually we are talking about a little bit more expensive tools and not so easy to use as a simple spreadsheet. Okay. Of course, you will have more automation, but that comes with a price on cost and knowledge. So and this is probably what will scare you. So how to build an S-curve? And when we are talking about S-curve, usually we are talking about the spherical curve. So it's the optimum progress. Imagine that everything goes well. Okay, and the formula looks quite scary, but it's actually not. And you only have two variables here: the current day and then the total number of days. Okay, so the duration. And then you have these two numbers, 3 and 8. And if you remember, when I talked about the S-curve, I talked about the inflection points. So when the curve shape change in the bottom of the S and on the top of the S. So basically, it's the 3 and the 8. Okay, those are the inflection points, and you can adjust them to your project, to your own reality if needed. And the output of this formula is basically a percentage for that specific day, and then you apply that percentage on the metric that you are plotting in the chart. Okay, so for example, you can plot the percentage of past test case or percentage of total test case between past, executed, failed, all of them. So you can always apply this percentage, and that will give you this optimum progress S-curve. Okay, and yeah, I know these mathematical things can be a little bit scared. Okay, so don't feel lost. You will realize that they are much simpler than what it looks like. And if you need help with that, just ping me, and I will be able to send you a Excel file with a sample that you can use to build your own S-curve. Okay, really simple. As soon as you read it, as soon as you start using it, you will realize that it's much simpler than what it looks like. Oh, but can I use it? So can I use the S-curve without an S-curve? That sounds like a stupid question, but actually you can. Okay, so the S-curve, when we are talking about the spherical curve, it's used for just to compare. Okay, it's like a baseline of the ideal world that you can use to compare your progress, to understand if you are according to the baseline, if you are late, or if you have more defects than expected. But even without using that S-curve, so forget all the maths, forget all the formulas that I showed to you, the S-curve is still there. It's the pattern in the data that is still there. Okay, and you can observe it. Just building the chart, even without the S-curve, you will be able to see that. And that just the chart, just to be able to understand the pattern of the data, it's quite important. Okay, and it can be quite useful. Let me give you some examples. So this one, okay, and as you can see, I'm plotting test case. We have 20 days. So 4 weeks phase, and you have the past, retest, failed, blocked, not executed, and then you have the milestone, so the go live. Nothing new here. Probably you saw these kind of charts already before, right? Hopefully. So green, all good, and well, this is the type of projects, the type of scenarios that we never see, right? When everything goes well according to the plan. From day 1 to day 20, all the tests pass, no fails. And as you can see, you have the S-curve shape, right? In the beginning, the team started quite slow, and then they earned some speed, and then on the last inflection point, they start to stabilize. Just, doing the remaining test case, the ones that were a little bit more complex, so additional scenarios. And the speed was a little bit slower. Okay, so this again, it's the ideal scenario. It's not what we have in our project, at least not what I've seen in my project. So this is the second one. Okay, and in this one, you can see that some test cases are still failing, right? So we have some fails, some red across the way, but you can still see the S shape. And even if it's not a perfect S shape, when you plot on top of your data, you will see the shape there. So in this case, we still have 5 days for the go live. Okay, so just looking to this data and try to imagine this as a pie chart. You know, if you have this last day 15 as a pie chart, it will be just a big green dot, right? Because almost everything is already passed. So just looking to that green dot, it will be really hard to understand if you will be able to succeed or not on the milestone, right? Because, for example, you will not be able to understand how many days you still have for the milestone. When you are looking to this, you can see the trend. And the trend in this case looks quite positive, right? You were able to execute and pass with success. You had some test cases that failed, but the developer team was able to provide you the fix. And in the last 2 runs, or the last 2 days, you don't have anything failing. So it looks like you will be able to achieve the go live milestone, right? You still have 5 days to go, but at this stage, all looks good that you will be able to achieve it. So, another example, okay? Again, everything green. So if you look to this as from the point of view of a pie chart, you will just say, well, you know, everything is green. Well, yes, we still have some tasks to be executed, but we don't have anything failed, so it looks good, right? It looks green from that perspective. But actually, if you look to the go live date, and if you have this scenario 5 days before, well, you know that you have a problem. Even if everything is passing, and again, you still have the S shape, but the S shape will end somewhere here on the around between 40 and 60, you know, still far away from the 100 test case that you are trying to execute. So again, just by plotting the same information in a different chart, you are able to understand the insight of the data. Another one, when you look to this, probably it's a little bit more close to the reality in most of the projects. So you have the test case that are failing, and you have the test case that are blocked. Okay, 2 things that we can see from here. And actually, if you look at the data, you start to understand that you will not have just one S-curve, you have multiple S-curves. So you can have the S-curve for the test case that passed, you can have the S-curve for the test case that failed, and you can even have the total S-curve, right? Again, we are always talking about cumulative values, so you need to use something that will produce these cumulative metrics. So what can we read from this chart? Okay, so we are 5 days, 1 week from the milestone. Are we green? Are we still green? Are we good to go? Or do we see any risk? Actually, we have 2 different risks. So as you can see, this red area, it's actually increasing day after day. So this is a very strong message to the development team that they need to increase the capacity. So the development team is not being able to fix the defects. So they are not being able to provide any fix, and that's why we still have this test case failing. So this is a very strong message to the development team, and this information, the chart, the data, can help you to explain that message. By the other side, on the blue, so the blocked ones, you see that you are blocked almost or from the beginning of the 2nd week in the project. It could be a dependency from the customer, it can be an environment, it can be test data, you know, all these different things that we are used to see in the projects that will block our progress. And what should worry us what the flag in this case is that after 2 weeks, we are still blocked. So we were not able to unblock this test case. And most probably, if we look to the trend, probably we will finish without being able to have this test case unblocked. So as soon as we start seeing this, we can raise a flag to the stakeholders, trying to understand who can help us to unblock this test case, or else we will fail in the final milestone. And the last one, just to give you also some more, let me check the time, just to give you some more examples. In this case, you have this green color, this yellow color, the tests to be retested. Okay? On the previous one, we had the backlog on the developer side. So the developers were not being able to deliver the fix. In this one, if you look to the red, you will see that they are able to deliver some fix. Right? Not yet 100%, but we are getting there. So as soon as we raise the defects, as soon as we fail the test case, they are able to fix them, and we are able to have the tests to be retested. But we are not actually succeed on that. So this is a very good message for the QA team, for the testing team. It means that we are lacking the capacity, and we need to reinforce our capacity to be able to test and to succeed on the milestone. So these are a couple of examples, and we are reaching the end. We only have 2 more slides, quick ones. So if you want to understand how you can improve after having all these S-shape, after understanding how you can use the S-shape charts, I challenge you to learn a little bit more about EVM, earned value management. This is a project management technique, and as you can see on the chart, it uses several S-shapes, and this will allow you to be a little bit more objective when you are saying, "Oh, we are late," or "We are earlier on time. We are not being able to deliver all the value that we planned." Just instead of saying that, you can actually use some formulas. You can use this technique to explain if you are late, how much late that means. Okay, one day, it's a couple of days, and also on, of course, not on the cost, but for example, on the test case that you need to deliver. So it's really interesting information, and you can see this as the next step. So final takeaways, as we are reaching the end of the talk. Don't use pies. Okay, don't use pie charts. They are only good when you have 2 or 3 different data points, and when they have really different values. If you have more than 3 data points, please don't use pies, because they will not help you to convey the message. And the second one is to use the S-curves. Even if you are not using the formula, get used to draw that shape, get used to understand the insight of in the information, just looking and trying to understand the trend and trying to understand that shape. That can help you a lot to predict and to anticipate some risks, some issues in the project. And last but not least, take a look into this earned value management. Probably if you have some experience with formal project management, you will know already this. But if not, take a look into it. It's not, it looks complex, it's not. And again, if you ping me, I will also try to include these on the sample Excel file that I will share. Okay. So, obrigado. Thanks, Chekur. Hopefully I said it correctly. And you have my LinkedIn address here. As I said, if you have any questions, or if you'd like to see also some sample Excel file that can help you to build these S-curve charts, just send me a message, okay? And I believe we still have some minutes for questions, if any questions.
Thank you so much, Sal. Indeed, we have one question.
Okay.
So it's coming from Melinda. Do you have any suggestion of tools or frameworks to collect the data and to create such charts?
Sorry, can you repeat the first part?
Yes.
If we have frameworks?
Yes, any suggestion of tools or frameworks to collect data?
Yes, as I said, yes, we have tools. For example, tools that will connect with Jira. That is most used defect management tool in our days. You have tools that will be able to extract this data. Okay, usually analytic tools, but I didn't explore that. Just send me a message and I can give you also some pointers. Most of these tools are commercial, okay? So you will need always to pay some money for it. And usually when we are talking about these kind of tools, as I said, they are not so easy. They are a little bit more complex. They will make it easier to collect the data, but not so much on looking into the data and creating the charts. I try to present something that everyone can use, can build without any excuse, right? We are all used to that. Oh, I don't have time, or I don't have money, or I don't have those expensive tools. In this case, just create a free account on Google Sheets and you can start using it, okay? In any case, as I said, yes, you have tools for that. Just ping me and I will send you the commercial links for those tools, okay?
Thank you, thank you. Any other question?
Yes, I guess Umut has a question. He's raising hand. I gave the permission. Hi, Umut, please ask your question.
Hi. First of all, thank Joel for the great presentation. It is, in my opinion, an important topic for any engineer to be able to communicate its findings and testing what we are doing is measuring the quality and reporting back with our findings to say what is ongoing with the product, but as well as you presented here, what is ongoing with the project that produces the product. Specifically the parts that you produced for the progress chart, which means the date doesn't reach the goal date, actually shows not the risk on the product, but the risk on the project.
Yep.
But I would like to say there is another pitfall in the whole, how should I say, data presentation model, is at the unit of the data that you're presenting or collecting. For example, the presentation or the graphics that you provide was focusing on the number of tests that can be selected as well. I am just providing a link to the chat to show that what different statistical metric or what the same statistical metric can come from a different data set. One of the issues is if you have, for example, 5 tests not executed out of 100, but if they're all on a important core functionality, which increases still the risk on the product success because that part of the functionality is never tested, even the number seems to be low.
Yeah.
Or, for example, we are using at my workplace the test trail from Grok software. It uses the pie chart, but one of the biggest issues I have is when I do not run a single test out of 100, it doesn't tell me what is the importance of that test or how much work that needs to be done for that test. To run that one test, maybe all the rest is mostly automation or script supported, but that one test will take 2 days just to set up and maybe 3 days just to crunch out the performance data which is collected, etc., etc. So actually, it is not only one metric that should be presented, in my opinion. It should be many, including the risk left on the product, risk left on the project. And that is why I think the ISTQB is also focusing more on the risk-based testing.
Yeah, and thanks, Sumit, for your comments. And yes, it's true. I only tried to present one way of doing this information. And as I said, you can use this technique with different metrics. So you can use this technique, for example, with test case, that was what I was showcasing, but you can also use it with defects. And when we are talking about defects, or even with test case, then you can split your data from different point of views. You can use priorities, or for example, if you're looking for defects, instead of just having the defects are open or closed or in progress or ready to be retested. For example, you can also have one important metric, that is the defects that are new or defects that are reopened. So if you have an issue where the defects are not being fixed at first, it could be important to expand your charts to show that information. So yes, what you said, it's true. You need to have multiple views, different views on the same data for progress and quality to manage priorities. So the tool that you can use, and in the end, you will always see this S shape, but I 100% agree with you. You will need to look to or to build the same charts with the different data sets, and probably use the different charts across the project lifecycle. Okay, so depending on the message that you want to send on your report, you can use one or the other. Okay, so thank you. I don't know if we have any more or if we run out of time.
Right now, we don't have other questions, but again, as Zell says, he is always available for everybody who wants to ask something, even if after now. So, again, thank you very much, Zell. It was really great.
Well, first of all, thanks a lot for your contribution. That was a really fantastic presentation.
Thanks.
And also, I'd like to thank you about your support to us throughout the process. You're so important for us. Thanks a lot.
Oh, thanks for your contribution to the community. Okay, I really appreciate it, as I said. So thank you.
Thank you. Bye-bye. Have a good
Bye-bye.
day.
Bye-bye. And congratulations for the anniversary.
Thank you.
Bye-bye.